So actually, all the things for the modeling of this structure we have completed. Now the next thing, that is what we have completed, the reading of all structural architectural drawing, deciding the positions of your vertical elements, and setting up all the basic things in your ETAP software, like in plan definition, over height definition, then definition of your material property, definition of your sections, okay, defining of all the sections, then modeling of the column, modeling of the beam, modeling of shear wall, modeling of column, everything we have completed. Now the next thing, we have to define what? Diaphragm, and we have to define the pier labels. So later on all the discussion will be in respect of your assigning of earthquake load, or it all are the the terms used in your earthquake loading and earthquake consideration. Whatever the later discussion will be, that is what all associated with your earthquake engineering, earthquake loading. Got it? So to understand all these things, it is very important to first clear all the basic concept in respect of calculating the earthquake load. Calculating what? Earthquake load. So let me take a simple example, so that through that example you can understand so many things for the earthquake loading and for the earthquake load calculation. So let me show you. Is it visible? Hello.
Yes, sir.
So I'm going to stop the discussion for the completion of this project. In between, I'm going to take this example, and the reason of taking this example is what? We have to understand so many things that are going to be that we will use for the earthquake loading in the ETAP software also. Okay. So very first thing, what does mean the base shear? What does mean by the base shear? That we need to understand. What does mean by the earthquake loading? That you need to understand. What does mean the seismic event? That you need to understand. Without of having the basic knowledge, if you are going to learn the advanced things, so that is not the way of learning. Am I right? Hello, Akhilesh sir.
Yes, very true. Yes,
Yes.
you need to
So
start from the
yes,
fundamental here.
Ryan, can you tell me what does mean by the base shear? No idea. That's a problem. If you are going to learn anywhere, so what they will tell you, like go to assign and do these things, and then your earthquake will be assigned. So that is not the way. Digambar, tell me, what is my base shear?
Base shear is, sir, maximum expected lateral force on the base of the structure. Means
Exactly,
base
good,
of the
very good. Yes, that's a thing. So that is what I'm means why I'm asking this question, because it is very important to understand. Without of having the knowledge and without of having the understanding of all these basic things, if you are going to look advanced things, so that is there will be no use of that learning. Got it? So first understand what does mean by the earthquake and what does mean by the base shear value. So earthquake is the seismic event. Earthquake is what? Actually the seismic event. And what does the base shear? That is what? Resultant force at the base of your structure during the seismic event. The maximum lateral force that is going to be act at the base of your structure, the maximum lateral force that is going to be act at the base of your structure during the seismic event, called as what? Hello. Hello.
base shear.
Base shear, got it? But
This
it
year.
is not the right definition. Now I'm going to say the right definition. The acceleration induced inertia forces going to be developed at the base of your structure during the seismic event is called as what? Base shear. Hello. The acceleration
Yes, sir.
induced inertia forces at the base of your structure during the seismic event called as base shear. Try to understand the basic formula for the calculating of base shear is what? Vb will equal to your weight of your structure multiplied by your acceleration. This is the basic formula to calculate the seismic base shear value, the maximum lateral expected lateral force at the base of your structure. So it is what? It is the multiplication of your weight of your structure multiplied by the acceleration, and this acceleration is going to be induced in your structure due to acceleration of your earth mass. So during this seismic event, what will happen? Your earth mass is going to be accelerated, and due to that acceleration, the acceleration induced inertia forces. It means due to action of this load and due to this seismic event, the resulting force is going to be developed, and that is going to be act over your structure called as what? Base shear value, and it will be maximum at its base. It will be maximum at its base. Okay, so it is called as base shear value. Is that all clear?
Yes.
Okay.
Yes, sir.
Second thing, the base shear will, one more thing you can notice here, VB base shear value is equal to W, means it is what? Weight of building. But I am not going to call it as weight of building, I am going to call it as seismic weight. Hello. Why I am going to call it as seismic weight? That's a different thing we will talk about later. So it is directly proportional to weight. Another VB is another directly proportional to your acceleration. With both of these two things, your VB value is directly proportional. So the intensity, that's why your structure will be subjected to very high intensity of the lateral force with a high magnitude of seismic event. So if the magnitude is more, means what? There will be the more acceleration in the earth mass. In the earth mass is having the more acceleration, and the weight of the mass of this weight of the structure is more. Seismic weight of the structure is more. So it combinedly will results very high intensity of the base shear, and that may become a cause of failure of your structure. Hello, Papu,
Yes, sir.
Ryan.
Yes, sir.
ओके, सो दिस इज कॉल्ड एज बेस शियर. आपके अर्थक्वेक के ड्यूरेशन में जो फोर्स डेवलप होता है, दैट विल बी एट द बेस ऑफ योर स्ट्रक्चर फर्स्ट, एंड दैट विल बी मैक्सिमम. ओके, नाउ this force will distributed over the height of your structure. These are lateral force, very high intensity of base shear value. It is not directly, means it is at the interface of, at the contact of your structure and the soil. This will be at the surface of interaction between your interacting surface between your earth mass and your structure. So this base shear value is going to be distributed over the height of your structure. This is going to be distributed over the height of structure, and due to that your structure will be under the acceleration, under the vibration. Got it? And this base shear value is what? Reversal action. The lateral force or this earthquake event is the reversal action. Got it? So this base shear value will be distributed over the height of structure. Hello.
Yes, sir.
Yes.
This base shear value is going to be distributed over your height of structure at different floor level. So basically, while making the calculation, later we will do this. Let me show you here. The distribution of the force we are going to calculate at different floor level. This different floor level, we are not going to calculate this lateral force. Actually the base shear value is here, and this distribution we are going to calculate only at the floor level. But what I'm saying, your lateral distribution will not only be at this floor level, it will also be present here. This lateral force may also be present at the intermediate level. This is also present maybe at the intermediate level. This is also present at the intermediate level. But my question is what? Why we are going to calculate this lateral force only at the floor level? Tell me. Okay,
क्योंकि सर
try to
जहाँ पे
understand. Okay, one more thing. यहाँ पर जो हम लोगों का एग्जाम्पल है, here we have to calculate the base shear value and its a distribution over the height of your structure. So that's the thing we have done in this example, that what we have calculated the base shear value and its a distribution over the different floor level, and that is actually the practice. But my question is that why we are not calculating a load at forces at the intermediate level? At here it will also be present, here it will also be present, here it will be also present, here it will be also present. So why we are calculating only at the floor level? Question.
At the
सर
joints,
जहाँ
yeah.
Yes.
because mass is concentrated at the floor levels.
Yes, Akhilesh.
हाँ सर, जहाँ पे मास होता है वहाँ पे फोर्स सबसे ज्यादा अट्रैक्ट होता है और वहाँ
Okay.
पे सब हाँ
Abu Bakar, Tafhim. Yes, Akhilesh sir, Ashok sir, you
फ्लोर
are.
लेवल पे फ्लो ट्रांसफर होता है ना।
Yes, Akhilesh sir, Ashok sir, Tafhim is also right. Your mass is going to be concentrated from the floor level. Your maximum mass of any particular floor is going to be concentrated through that particular floor. Not getting? Okay, try to understand. Suppose any building is there like this. Those who are not getting, okay, okay, okay. So this is your structure. So the beam will be at this floor level, slab will be at this floor level, the weight of the dead load or the weight of this column is going to be concentrated at this point. This column load is going to be concentrated at this level. So basically at this level the slab load is going to be concentrated from this level. The weight of the beam is going to be concentrated from this level only. Column load is going to be concentrated at this load. So overall the maximum actually the of any particular floor, the load is going to be concentrated through that particular floor. So at this level the mass is very large. Actually the weight, the mass is what at this particular floor is going to be concentrated from this level. For this particular floor, if you are talking about this particular floor, the mass of this entire floor is going to be concentrated through this level. That's why the masses at different floors are very large, or I can say the weight of the total particular floor is going to be concentrated through that particular floor. Okay, if I am going to consider here, so at this point what will happen, only this column load is going to be concentrated at this point. That will be very minor, that is not needed to consider. That's why we are calculating the distribution of the base shear only at a different floor level. First thing. Second thing, I told you at any particular point the shear lateral force or shear value will be directly proportional to acceleration, that will be constant, multiplied by your weight, seismic weight of that particular floor level. Hello.
Right, right.
Okay, so at that's the reason, that's why we are calculating the lateral forces, distribution of the lateral forces over the height of your structure only at the particular floor level. And these masses, that is the mass of the your slab, mass of your beam, mass of your column, and applied loads, all that's combinedly at any particular floor, we are going to call it as what? Hello, can you guess? Lumped
lumped mass.
masses. Hello. Can you
Yes
repeat
sir,
it
lumped
once?
mass.
Lumped mass.
Lumped masses.
Lumped masses. We are calling it as lumped masses. So if you are going to deal any problem manually, if you are going to deal it, so at any particular floor, you have to calculate the lumped masses. Okay, and that will combines your dead load of that particular floor plus all the assigned load of that particular floor. That will give you total seismic weight of that particular floor. So the lumped mass at this particular floor, lumped mass at this particular floor, lumped mass at this particular floor, and at this level, at this in respect of this lumped masses, we are calculating the distribution of the lateral forces. Hello, is that all okay?
Yes sir.
Right.
So in this example, so actually these all things were done by the software also. ये जो चीजें मैं आपको बता रहा हूँ, ऐसा नहीं है कि ये सिर्फ मैनुअली करना है हम लोगों को, यही सारा रिजल्ट आपको निकाल के देगा। आप कितना भी कॉम्प्लिकेटेड प्रोजेक्ट ले लो, कितना भी हाई स्ट्रक्चर ले लो, यही सारे रिजल्ट आपको इसमें चेक करने हैं। सॉफ्टवेयर भी आपको बेस शेयर वैल्यू देगा और लैटरल फोर्सेस डिस्ट्रीब्यूशन देंगे। दिगंबर, पप्पू, रयान,
Yes, sir.
getting? So this is actually the thing, lateral forces we have to calculate. So in this example we have to calculate the base shear value and its a distribution over the height. That is only the question, but along with this thing we have to learn so many terms. Okay, so come back, very interesting. A 4-story reinforced concrete commercial building is there. Hello. A 4-story reinforced concrete commercial building is there. What type of building is there? It is
Commercial.
reinforced concrete, and what type? Based on utility?
Commercial, sir.
Commercial.
Forget our project that we are dealing. Okay, forget that. The building is located in seismic zone. Hello.
4.
4.
Of
So
course.
our India is divided into 4 seismic zones based on the past data, means based on the intensity of the uh, 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 like intensity, and I can call magnitude of earthquake or seismic event of different cities of different regions. The entire India is divided into 4 zones. Entire India is divided into 4 zones: zone 2, zone 3, zone 4, and zone 5. Hello.
Right.
It is
Yes,
not
sir.
starting
Right, sir.
from 1. Remember, it is starting from second. So second, third, fourth, and fifth. Four zones are there. Okay. So different zones are there. So if you are if you are in zone 2, so there is a possibility of less intensity and magnitude of seismic event. There will be less intensity of magnitude and seismic event, intensity and magnitude of seismic event. If you are in seismic zone 3, so what will be there? There is a possibility of more intensity and magnitude of seismic event is to be happen. There will be the possibility. If you are in seismic zone 4, there will be the more chances of more magnitude and intensity. If you are in seismic 5, that is very very dangerous. There is a possibility of very high intensity of magnitude and intensity seismic event is going to be happen. If you are going to design your structure in seismic zone 5, so you need to take more care for the safety against your seismic event. If you are going to design in the seismic zone 4, you have to take again more safety. If you are in seismic zone 3, there will be some relaxation. If you are in seismic zone 2, there will be the more relaxation. Hello.
Yes, sir.
Okay, but can you tell me one thing is there? So many practical things we also have to discuss along with the example. Tell me, is it not possible that your seismic zone 2, like, okay, let me show you. See, the code that we are following for the calculating the earthquake load is IS 1893 2016. The old revision of this 1893 was IS 1893 2000, 1893 2002. That's the oldest revision, old revision, and latest revision is what? IS 1893 2016. So it is the latest one. It is what? The latest one. So here the seismic zones, 4 seismic zones are. Let me show you. Okay, see, seismic zone 3, seismic zone 3, seismic zone 2, seismic zone 4, and seismic zone 5. So Bhuj, the part of it is the part of Latur, I think. Hello, am I right or wrong?
Bhuj is in
नहीं
Gujarat.
सर,
It is
गुजरात
in
में है सर.
Gujarat. Okay,
लातूर सर महाराष्ट्र में है.
okay. Bhuj कहाँ पर है ये?
गुजरात में है सर भुज.
Gujarat.
Guj. Okay. So there was a very high intensity and magnitude earthquake was happen. Hello.
Yes, sir. Yes, sir.
Right.
So
Yes.
that was very disaster. So actually this is what we are going to consider seismic zone 5. Before of that, in if you look IS 1893 2002. So this was in I think in zone 3. I think it was in zone 3, 2 or 3 it was.
2 में था सर.
2 meta, right. In Bhuj, it was in zone 2. Now here in the 2016 version revision, it is needed to take in zone 5. So your earthquake event is totally unpredictable. Hello, that I
Yes,
want
sir.
to explain. So here it is Ajmer in seismic zone 2. So my question is that it is not possible Ajmer in next year. It should not happen. But we are going to consider suppose Ajmer which is in seismic zone 2. So it is not possible that it is going to experience the intensity and magnitude of seismic event of the zone 5. It is possible or not?
Possible,
हो
sir.
भी सकता है, नहीं भी हो सकता है सर.
हो सकता है, नहीं भी हो सकता है. इट इज टोटली अनप्रिडिक्टेबल. It may
Yes.
possible that if you are going to construct your structure in Bhuj by considering by considering zone 5 means you are giving the more safety to the structure, but in next 50 years your Bhuj is not going to experience any kind of any seismic event. Is it possible or not?
Possible.
Possible.
पॉसिबल है सर.
जहां पर आप कंसिडर कर रहे हो, सेफ्टी दे रहे हो in respect of assigning of earthquake load, and you are going to provide the ductile detailing also, but your structure is not going to experience any seismic event throughout its life. Suppose we are considering 50 years year of your life of your structure. So throughout the life of this structure is not going to experience any earthquake. On the other side, in let's say Allahabad, you are going to construct the structure and you are not giving the importance. IS code what IS 1893 says that 13920 113 IS 13920 means the ductile detailing. If your structure is, if you are going to apply the earthquake load and if you are following the ductile detailing, so it will be very safe against your earthquake load. हेलो, अगर आप
यस सर.
earthquake भी कंसिडर कर रहे हो और फिर ductile detailing भी कर दे रहे हो means your structure will be very safe. हेलो.
Yes, right.
Yes, sir.
सो यहाँ पर हम लोग इलाहाबाद के लिए क्या कर रहे हैं? सो IS 13920 what is saying that okay, for the structure which is located in the seismic zone 3, seismic zone 4, seismic zone 5, it is compulsory to follow this ductile detailing. Hello.
यस सर.
But there is some relaxation if your structure in seismic zone 2. Hello.
यस सर.
आपका स्ट्रक्चर अगर सिस्मिक जोन 2 में है, सो यू हैव एन ऑप्शन. आइदर यू कैन निग्लेक्ट दिस कोडल रिक्वायरमेंट और यू कैन कंसिडर. इफ यू आर कंसिडरिंग दैट्स वेल एंड गुड. और अगर आप निग्लेक्ट करते हो, सो कोड इज सेइंग दैट ओके देयर इज एक्सेप्शन टू कंसिडर दिस कोड फॉर द स्ट्रक्चर विच इज लोकेटेड इन सिस्मिक जोन 2. लेकिन हम लोग क्या कंसिडर कर रहे हैं? फॉर द इलाहाबाद आई एम नॉट गोइंग टू कंसिडर द डक्टाइल डिटेलिंग, बट आफ्टर द कंस्ट्रक्शन ऑफ योर स्ट्रक्चर in next 2 years your structure is going to be experience very high intensity and magnitude of seismic event. क्या करेंगे आप बताइए? हेलो.
At that point of we cannot do anything. It has
We
to.
can't do anything. Your structure failure will be there, collapse will be there, and what will happen we don't know, but yeah, damage will be there definitely. और यहाँ पर
Yes, sir.
फिफ्थ जोन में लाइक सपोज गुवाहाटी हम लोग कंसिडर करेंगे. फॉर द गुवाहाटी आई एम गोइंग टू कंस्ट्रक्ट द स्ट्रक्चर एंड आई एम गिविंग very सेफ्टी in respect of considering the earthquake load and ductile detailing. Everything I have done in respect of the codal requirement, but throughout the life of structure your structure is not going to subject any earthquake load. So this is your, that the thing is what earthquake is totally unpredictable thing. Hello.
Yes, sir.
Right.
Okay, it is totally unpredictable thing. It may possible that the region which is here in suppose suppose Bhopal here it is in seismic zone 2, but in next 2 to 3 years, just we are considering should not happen actually. Okay, so your Bhopal may subjected to very very high intensity and very high magnitude of earthquake or seismic event. So may possible that in upcoming revision of your IS 1893, there will be the possibility that Bhopal will be in the seismic zone 5. That will be possible or not?
Possible, sir.
Okay, so
Yes.
that's
After
why.
the occurrence.
Okay, it is what totally unpredictable. Seismic event is what totally unpredictable. Remember this thing. So one thing we learn from here is what your entire country is divided into four zones. Actually, the seismic zones 2, 3, 4, and 5. Yes. So, your type of building is commercial building, reinforced concrete building. The building is located in the seismic zone 4. The soil characteristics are medium stiff. The soil characteristic is what? Medium stiff, and the entire building is supported on raft foundation. Your structure is supported on raft foundation, and the type of the soil. So, there are, as per IS 1893-2016, the type of the soil is what? Three types. Soil is having the is of three types. One is very stiff, then medium stiff, and loose soil or clay soil. Hello. Okay. So I will let you know later. The entire building is supported on the raft foundation. The reinforced concrete frame is infilled with brick masonry. It is infilled with brick masonry, and the lumped masses due to dead load is 12 kilonewton per meter square on the floor level. What is saying that it is G plus what G plus three floors. This ground, first, second, and third, or totally if you are counting the floors, so 1, 2, 3, 4 levels are there. So lumped masses due to dead load. Due to dead load means what? 12 kilonewton on the floor level. 12 here, 12 here, and 12 here. Okay, lumped masses due to dead load on the floor level and 10 kilonewton on the roof level. 10 kilonewton on the roof level. Is it right or wrong? Hello.
Right.
Similarly,
Roof is less.
the lumped weight due to live load is 4 kilonewton. The lumped weight due to live load is 4 kilonewton on the floor level. Here 4, here 4, and here 1.5. Getting or not?
Getting.
Okay. Remember this. Now come down. So this is what all the given data is all given data. Just come down. Solution. It is the in-plant definition of this structure is what? Four bays are there along x direction 1, 2, 3, 4, and along y direction 3 bays are 1, 2, 3. Dimensions are 5 in both distances between the two between one bay is what? 5 meter in x and in y direction. Over the height it is what? First floor at a height of first slab at a height of 4.2 kilometer 4.2 meter, and 3.65 3.65 3.65 typical height is there. Hello, getting or not?
Getting.
Okay, your structure is in seismic zone 4. So we have to, okay. So the basic formula for calculating the base shear value is what? VB is equal to AH, acceleration value, horizontal acceleration, multiplied by your seismic weight. So your horizontal acceleration value is equal to zone factor divided by 2 multiplied by I by R multiplied by SA by G. Hello, Akhilesh sir.
Yes, sir.
Okay, this is the formula. So these basic terms first we need to calculate. Then lumped seismic weight we have to calculate overall seismic weight of your structure. Then response reduction value you need to calculate. You need to know importance factor, you need to know zone factor, you need to know all this value. If you are having, then that all value you can put here. So ah value you will get, seismic value, seismic weight you have to calculate, multiplication of these two things, you will have the base shear value. Okay, so one by one we will see. Zone factor, it is what? 4. Seismic zone is what? 4. Zone factor will be what? So IS 1893 will tell you about zone factor value for the seismic zone 4. Tell me, what is the value for seismic zone 4?
0.24, sir.
0.24. Those who are in masters in degree and want to work as a structural engineer, want to means they are going to face any interview, so they have to remember this thing. What are the different zones? How many number of different zones are, and their respective zone factor value. Okay, so in the second zone the value is 0.1, in the third zone 0.16, in the fourth zone 0.24, in the fifth zone the value will be what? 0.36. Okay, so that's I'm going to put here. Zone factor value will be 0.24. Type of the frame. There are two types of the frames as per suggested by the code. One is what? Ordinary moment resisting frame. Another one is what? Your moment resisting frame. Hello. What are those? Ordinary moment resisting frame and special
Yes, sir.
moment resisting frame. So what is the difference between these two things? Can anyone?
सिर्फ बीम कॉलम है तो ऑर्डिनरी हो गया, बीम कॉलम और शेरवाल है तो स्पेशल.
Who said? Ordinary moment resisting frame is there and special moment resisting frame is there. Very simple. If we are going to follow the ductile detailing, as per as 13920, at that time the building will be called as special moment resisting frame. Hello, are you getting?
Yes.
If we are going to follow IS 13920, IS 13920, which is the code for the ductile detailing, if you are going to follow for your structure, so that structure is going to become special moment resisting frame. If you are not going to follow the ductile detailing, but yeah, earthquake loading you are going to consider, so it is going to become what? Ordinary moment resisting frame. Is that all clear or not?
Clear.
Hello. Yes. So response reduction
Sir, what
factor.
about steel frames?
Sorry.
What about steel frames? There are steel frame building, ordinary and special, and base frame system also there.
Sorry.
Sir, base frame system also there, no?
Steel
OBC
structure.
and yes, sir.
There is a different consideration for the steel structure. This is only
Okay.
about your RCC structure.
Okay.
Okay. So yeah, my another question is what? So actually, see, response reduction value we have to consider 3, and for ordinary moment resting frame and for situation moment resting frame, we are considering 5. So look at what will be the effect on your VB value, base shear value. So here, see, VB is directly proportional to age, and your age is equal to your Z by 2 I by R and multiplied by SA by G. So if you look over these all constant values, so VB is going to be increased if there is an increase of Z value, right or wrong? Hello.
Right, sir.
Right. Your VB value is going to be increased if your I value is going to be increased, right?
Right.
SA by G is a single value. Okay, don't consider it as a different SA and then G. It is SA by G acceleration value. Okay, so it is again directly proportional to VB or not?
Right.
Directly proportional. But your two times R, it is what? Hello, R is inversely proportional or directly proportional?
Inversely.
Hello.
Inversely proportional.
So if R value is going to be increased, so your VB value will be what? Increase or decrease?
Decrease. Decrease.
Very good, very good. So actually what? अच्छा, आज तो क्विक लोडिंग हम लोग कैलकुलेट कर रहे हैं और आपको स्ट्रक्चर लाइक सपोज यू आर गोइंग टू डिजाइन योर स्ट्रक्चर इन सिस्मिक जोन 5. हेलो, सो इट्स वेरी क्रिटिकल, राइट?
Yes.
ओके, अभी वहां पर हम लोग डिजाइन करने जा रहे हैं और मैं वीबी का वैल्यू कैलकुलेट करने जा रहा हूं. सो अगर मैं इसको रिमूव कर दूं सो मोर वैल्यू मिलेगा वीबी का.
Hmm.
If you are getting more value of VB, if you are going to calculate more value of VB, so that will be the safe, or if you are getting the less value of VB, so that will be the safe. Which one will be the safe? General consideration, thinking.
More
Base
value.
value. Base value.
आप जितना ज़्यादा लोड के लिए डिज़ाइन करेंगे तो उतना ज़्यादा सेफ रहेगा ना.
सेफ रहेगा सर, लेकिन इकोनॉमिकल नहीं होगा.
तो ठीक है ना, अर्थक्वेक है तो सेफ्टी मीन्स दिस इज व्हाट आफ्टर द कैलकुलेशन वीबी वैल्यू वी आर गेटिंग. ये हम लोग बढ़ा नहीं रहे इसको. मैं क्या कह रहा हूं कि आर मत कंसिडर करिए, मैं आपको ज्यादा करने के लिए नहीं कह रहा हूं. हेलो, 2 times 3 times. हेलो,
ओके सर.
whatever
sir.
by the calculation you are getting, but I am saying that what, why you are going to reduce this value? It is what R in its denominator. So why we are going to reduce the VB value? It is good for us to have the more value, because our structure will be designed for the more load. There will be the more safety to the structure. But the question is what? Why we are going to reduce this value? The question is that. First question. Second question. This is what called as, if we are going to reduce it, that's why we are calling it as response reduction factor. What we are calling?
Response reduction factor.
A response reduction factor. So first my question is what? Why we are going to reduce it? Second question is what? Here it has suggested that for the ordinary moment resisting frame, the value we have to consider as 3. For the special moment resisting frame, we are for ordinary moment resisting 3, and for special moment resisting it is 5. रिवर्स है यहाँ पर. एक्चुअली में होना ये चाहिए था कि स्पेशल मूवमेंट के लिए 5 देना था. यहाँ पर तो हम लोग डक्टाइल डिटेलिंग फॉलो नहीं कर रहे हैं यहाँ पर. हेलो,
Right.
हम लोग यहाँ पर डक्टाइल डिटेलिंग फॉलो नहीं कर रहे हैं. हेलो, तो 3 कंसिडर कर रहा है और यहाँ पे डक्टाइल डिटेलिंग फॉलो कर रहे हैं तो यहाँ पर 5 कंसिडर कर रहा है. हेलो, okay, my question is what, why we are reducing this VB value and why this difference are? For ordinary it is 3, for special it is 5. पहले तो ये क्वेश्चन आंसर दीजिए कि इसको रिड्यूस ही क्यों कर रहे हैं हम लोग.
क्योंकि सर जो अर्थक्वेक लोड आता है सर, वो हमेशा नहीं लगता है. मतलब किसी भी टाइम आ सकता है, एक पर्टिकुलर टाइम पीरियड के लिए. इसीलिए पूरा अगर लेंगे तो सर तो इकोनॉमिकल नहीं होगा, वो ज़्यादा उसमें हो जाए. इसीलिए उसको रिडक्शन करके हम डिज़ाइन करते हैं.
Okay. Second, yes, anyone else?
The probability is less.
Yes, Vikas.
हम लोग डिजाइन के वक्त ही बहुत फैक्टर ऑफ सेफ्टी लेते हैं. कंक्रीट सब में भी हम लोग फैक्टर ऑफ सेफ्टी लेके चलते हैं. जैसे ही एक्यूमुलेट होते वो बहुत हो जाएगा और हमारा सेक्शन ज्यादा अनइकोनॉमिकल आएगा. इसीलिए उसको थोड़ा इकोनॉमिकल की तरफ ले जाने के लिए हम लोग रिडक्शन फैक्टर यूज करते हैं.
Very good, very good, very close, but not 100%. Yeah, but yeah, up to 80% you are right. Anyone else?
Two reasons. One is the already taken factor of safety, the material properties and the
Okay,
load factors, and then probability is less of earthquake coming.
okay, yes. Okay, so it is what a response reduction factor. So it is what because is right. We have already taken so many factor of safeties for the designing of structure, like over the material we have taken the safety, over the loading we have taken the safety, and at so many points we have taken the factor of safety while designing of structure, while positioning of elements we have taken the means more number of columns, more section sizes. While deciding the positions of the beams, we have taken the extra beam positions, extra beam section sizes. Slab depth we have already taken more. So overall, in different aspects, we have already taken very large factor of safety for the designing of structure. But the thing is what all those extra factor of safeties we are going to utilize here to reduce this base shear value. But the question is what why we are going to reduce it? Again the same thing, why we are going to reduce it? So as we have discussed that your base shear value, sorry, your seismic event is unpredictable. It may be there or it may not be there. It may happen after the construction of the project, after the completion of the project in next 2 to 1 years, and there is the possibility that throughout the life of structure, your structure is not going to experience any earthquake. So both the possibilities are there. The probability is there. So that's why first read the title. Hello, of this code. Hello, what is the title of this code? Tell me.
Earthquake resistant design.
We are going to make your structure as earthquake resistant. If I am going to remove this R value, if I am going to remove this R value from the formula, the title of this code will change. Hello. It will become the criteria for earthquake proof design of your structure. Hello.
Right.
Earthquake proof design of your structure. So meaning is what? Here we are going to allow some kind of failure in your structure. Here we are going to allow some kind of failure in your structure. We are not going to make our structure completely earthquake proof. We are not going to make our structure as completely earthquake proof. So what will happen? We are making some arrangement, we are making some provision for the resisting the earth seismic event, but it will not become the earthquake proof.
Right.
So there are three conditions. In the first case, when your structure will be subjected to very less intensity of the earthquake. In the first case, when your structure is subjected to very less intensity of the earthquake, so what will after experiencing the earthquake, after can you wait for a minute? Hello, just a minute, just a minute.
response
Okay,
reduction.
when less intensity of earthquake is there, or in other case we can say that if the intensity of the earthquake is less than the resisting capacity of your structure, so what will happen? There will be no impact to your structure. There will be no impact to your structure. Hello, there will be uh, there will be no need of repair. There will be no collapse, there will be no any kind of failure, so there will be no need of repair. Hello. In the second case, what will happen? In the second case, what will happen? The intensity of this seismic event is such that it is your structure is losing its stability. the intensity of lateral force is such that your structure is going to lose its what stability. So there is the possibility of development of the failures, development of the cracks, and your structure stability may be maintained if you are going to provide the repair. If you are going to do the repair, your structure will become again stable to stand. Hello. In the third case, what will happen when your structure is going to be subjected to the seismic event which is very large, which is having the very large intensity beyond of the capacity of structure. So what will happen? Again, your structure is going to be under the collapse. Your structure is there will undergo to the collapse, and there will be the loss of life of your structure. Hello. But we are going to make your design such that, hello,
Yes.
we are going to make our design such that, yeah, in this third case, your structure losing its stability, losing its strength, is going to be collapsed. But there should not be a complete collapse of your structure. There should a chance to the people who is living inside of this kind of structure, which is going to be subjected to very high intensity of the earthquake. There should a chance to get out from this structure. First thing. Second thing, there should not be a complete collapse of this structure. Yeah, collapse will be there, damage will be there to the structure that may not be repairable. Hello.
Right.
Cannot recover. Cannot recover. It is called as survival limit state. Hello. It is damage control limit state. Hello. It is called as what? Survival limit state. This is called as damage control limit state. Okay. So in the third case, what? Recovery is not possible. Recovery is not possible, but for instance, we are going to make our structure, design our structure such that it should capable to, it should not, there should not be a complete collapse, so that it is not going to harm to the people which is living inside of this structure. They should get sufficient time to get out, to escape out from this structure. Getting or not?
Got it, sir.
So as you are seeing here, we are not going to make our structure in any case as earthquake proof. हम लोगों ने यहाँ पर कहीं पर नहीं कहा कि कितना भी इंटेंसिटी ऑफ अर्थक्वेक आ जाएगा, योर स्ट्रक्चर विल नॉट गोइंग टू एक्सपीरियंस एनी काइंड ऑफ फेल्यूर, एनी काइंड ऑफ इम्पैक्ट. मैंने कहा ऐसा कहीं पर?
No, sir.
No. In every case, we are going to allow the collapse if it is beyond of the capacity of your structure, because we are expecting this much intensity of earthquake will happen. So if your structure, if your structure, if the load is less than of your structure strength, so okay, no impact will be there. If it is beyond of the capacity of your structure, yeah, there will be the damage that will be repairable. But it is very high intensity of seismic event is there, so we are taking for this force. In that condition, your structure should maintain its stability. Hello. As long as possible. Hello.
Yes, sir.
Right.
Okay, that's why we are going to make our structure as earthquake resistant, not earthquake, hello,
Proof.
proof. Is that all okay?
Yes.
Again, this is the answer for first question, why we are considering this R value. This was question. My second question is what? Why this differentiation is there? For the ordinary it is 3, for special it is 5. As you told, like R value, it is actually the summation of all the over safeties. So it is what? The R value is a resultant value of your over strength factor multiplied by redundancy factor multiplied by damping factor multiplied by ductility factor. Hello. The product of all these over safeties will give you a response reduction factor. Over strength factor is what? All the over strengths like your material over safety factors, partial safety factors, your loading over safety factors, and all other kinds of over safeties comes under the over strength factor. Redundancy factor, all the extra elements that you are considering in your structure, that comes under the redundancy factor. And damping factor is what? Your structure is itself a damper. What does it mean by the damper? So it is preventing the lateral deformation of your structure. Hello. When the structure is going to be vibrate under the seismic event, so what will happen? It will undergo the deformation. So to control the deformation of your structure, your structure should have the additional damper. If very high intensity of lateral force is there, and under that lateral force your structure is going to experience very large deformation, and if you want to control this deformation, you have to put the damper. Hello, sorry, what I'm calling? Hello,
सर
yes, it is the damper. Hello, so tell me, so what will happen? Extra you need to provide, but your structure itself a damper. Hello, you all are with me or not?
Yes, sir.
yes
So
sir
structure is also having the capacity to control the deformation of your structure up to a certain extent. So if that property you are going to utilize, so it is called as damping factor. So over strength factor is there, and redundancy factor is there, and damping factor is there. But normally this damping factor we are considering one. We are considering it as one. So three terms will be there that are going to be matter. This R value is what? Over strength factor, redundancy factor, and third one is your ductility factor. Okay, so what about this ductility? The possibility of your structure or component part of your structure or the material of your component to undergo a large deformation without of its failure, called as ductility. Hello, what is the definition?
Right, sir.
the the capacity of your entire structure or component part of your structure or the material of your element to undergo a large deformation without of its failure, called as what? Ductility. Hello, and the ductility of your structure were controlled by the provision of the reinforcement in that structure. Hello, because only your concrete is what brittle material, and your steel is actually the ductile material. So ductility of the structure were controlled by only what?
Still, sir.
Steel. So if if I'm going to provide the more reinforcement in my structure, so it will become more ductile or less ductile? Hello, more ductile. Okay, so the thing is what, like what I told you about special moment resisting frame. What is the difference between these two? Ordinary moment resisting frame, tell me. When to call to the structure is special moment resisting frame, when you call to the structure ordinary moment resisting frame? Fast.
Ordinary momentum resistant firm is not as a requirement ductile behavior, sir. And a special moment resisting frame is a follow the ductile behavior.
Very simple. If you are following IS 13920, then it is special moment resisting frame. If you are not going to follow the detailing as per IS 1893, that will become what? IS 13920, that will become what? Ordinary moment resisting frame. So in special moment resisting frame, you are going to provide the more reinforcement, right? And in ordinary moment resisting frame, you are going to provide the less reinforcement. Hello,
right sir.
So if the more reinforcement is there, so ductility will be what? More. And if less reinforcement is there, so ductility will be what? Less. Hello. So that's why if the more ductility is there, so the resultant R value will be more. If the less ductility is there, so resultant R value will be what? Less. That's why for ordinary moment resisting frame, R value we have to consider as 3, and for special moment resisting frame, R value will be we have to consider as 5. Hello.
Yes sir.
Come back.
Right.
So here for the special moment resisting frame, we have to consider the R value as 5. Importance factor, based on the importance of your structure, the importance factor you have to consider. So 3 types of structures are there, like commercial structure and residential is there, public structure is there, and temporary structure is there. According to the type of structure and based on its utility, based on its importance, the importance factor we have to choose. See, importance factor, important service and community buildings or structure, like government structure, government buildings, school buildings, and any kind of public structure I can call, which is need to have the more importance, which is need to have the more importance. That's why we need to consider 1.5. For residential commercial building we have to consider 1.2. For all other buildings which include your temporary structure, for that importance factor you have to consider what? 1. Tell me, in our problem, what type of building it is?
Commercial building sir.
Commercial building. So importance factor will be what?
1.5 sir.
Sorry?
1.2 sir.
1.2. Don't do the mistake. Hello. Akhilesh sir, are you there or not?
Yes, sir.
Okay. Next, to find the seismic weight at the floor level, seismic weight, not the weight. Why I'm not going to call it as weight? Because weight will include only the dead load. Weight will include only the dead load. But here there will be the consideration of live load also. There is a consideration of what? Live load in calculation of the lumped masses. So actually we need to calculate the lumped masses at different floor level. At different floor level. Okay. So at this particular floor, if I need to calculate the total load at this particular floor, so I had to add the dead load plus live load. At this particular floor, how much dead load is there? Hello.
12 sir.
12. And live load how much? Lumped weight due to live load is what? At the floor
4.
level it is 4. Total how much it will become?
16.
16. Is it right? No, it is wrong. It is wrong. Actually, for the dead load there is no any clause. 100% you have to consider, but there is a consideration, there is some reduction as suggested by your code for live load consideration. Come to your IS code and let just try to understand what reduction is possible. Okay, is it visible?
Yes sir.
Read this clause. For the calculation of the design seismic forces of the building, that is base shear value, imposed load means your live load on roof. Roof means your terrace need not to be considered. Hello.
Right sir.
आपको टेरेस पर लाइव लोड कंसिडर करने की जरूरत है?
नहीं है सर.
नहीं है. Okay. But weights of the equipment and other permanent fixed facilities should be considered. Okay, not in use in this statement. The reduction of imposed loads mentioned in the table 10, this one, table 10, are not applicable to that part of the load. Okay, exclude that. Now 10, table 10, it is what? There's some reduction for your live load while the calculation of the seismic weight, live load. So if your live load on the floor level, except excluding your terrace floor, because at the terrace level, at the roof level, you don't need to consider the live load, you can neglect that. But for the other lower floors, if your live load is less than or up to 3 kilonewton per meter square. Hello.
Yes, sir.
So how much you have to consider only?
25%, sir.
75% you have to neglect that, and only 25% you have to consider. If your live load is more than 3 kilonewton, so how much you have to consider?
50%, sir.
50% you have to left. Understood or not?
सर इसके बिहाइंड लॉजिक क्या है सर, वो नहीं समझ में आया
क्या हुआ?
सर। इसके बिहाइंड लॉजिक क्या है, मतलब 25% और 50% के बिहाइंड लॉजिक क्या है सर?
Logic, okay. Actually, see, during the seismic event, what possibility will be there? आप बिल्डिंग में ही रुकना चाहेंगे या बिल्डिंग से स्किप करना चाहेंगे?
यस सर, निकलेंगे सर।
Are you getting?
यस सर।
That's the logic, nothing else. During the seismic
Okay, sir.
event, most of the times, what will happen? People are trying to getting out of this structure. So why unnecessarily you are going to consider? Because आपको पता है कि आपका वेट बढ़ेगा तो सिस्मिक लोड बढ़ेगा कि नहीं बढ़ेगा?
यस सर, बढ़ेगा।
वेट के ऊपर मैंने पहले ही आपको बता दिया, वीबी इज डायरेक्टली प्रोपोर्शनल टू योर वेट। अब जैसे जैसे आप अननेसेसरीली अगर आप वहां पर कंसिडर करेंगे, लाइक यू आर गोइंग टू डील विथ सपोज G+20 फ्लोर बिल्डिंग। अभी G+20 फ्लोर बिल्डिंग पर आपने कितना लोड लिया होगा, लाइव लोड? एंड वाइल कैलकुलेटिंग दी सिस्मिक लोड, अगर आप वो 100% लाइव लोड कंसिडर करने जा रहे हो, सो विल इट बी वर्क? विल इट बी इकोनॉमिकल? नो। पॉसिबिलिटी है कि बहुत सारे लोग वहां से स्किप आउट हो जाएंगे। हेलो।
लेकिन कंपैरिजन बाकी जो लाइव लोड की कंपैरिजन, तो एक आदमी का वेट तो सर बहुत कम होता है।
नहीं, नॉर्मली रेजिडेंशियल बिल्डिंग में, कमर्शियल स्ट्रक्चर में लाइव लोड हम लोगों का क्या होता है? पर मींस वी आर ह्यूमन बीइंग्स, आर वी आर कंसीडरिंग आवरसेल्फ एज अ लाइव लोड।
यस सर।
ओके, तो ये कंसिडरेशन होता है। ठीक है, अगर किसी और स्ट्रक्चर में का डील कर रहे हो और वहां पर वो स्ट्रक्चर वो लोड परमानेंटली आपके स्ट्रक्चर पर रहेगा, वो स्किप आउट होने वाला नहीं है, तो फिर आप उसको कंसिडर करिए। देन देयर इज नो ऑप्शन।
सर उसमें 75% आप है ना वो उसको कंसिडर नहीं कर रहे हैं लोड को,
हाँ
सिर्फ 25% ही कर रहा है।
हाँ।
तो इन कंपैरिजन अगर वो लाइव लोड के कंपैरिजन में से अगर कोई भी पर्सन है वो अगर निकलता है तो बहुत ज्यादा तो मेरे ख्याल से फर्क नहीं पड़ना चाहिए लोड पे।
किसके ऊपर सर?
सर जैसे लाइव लोड हम लोग लेते हैं 3 किलो न्यूटन, तो अगर उसमें एक पर्सन का वेट और लोड अगर हम कैलकुलेट करें और उसमें जैसे इसमें कह रहा है कि 75% आपको नेगलेक्ट करके चलना है 3 में, अगर बिलो 3 हो तो पर्सन का सर उसमें 75% है ना हटा देना, ये नहीं समझ में आया सर। क्योंकि इन कंपैरिजन कोई सामान और है ना एक आदमी के में तो बहुत फर्क होता है सर। अगर एक फ्लैट में अगर 6 जन भी हैं तो अगर 6 जन निकलते हैं तो बाकी तो सर बहुत ज्यादा तो नहीं उसमें वो फर्क आने वाला है वेट में।
नहीं तो वो अदर वेट वगैरह तो कैलकुलेट करेंगे ना सर, वो तो हम लोग करने वाले हैं। अच्छा, एक रेजिडेंशियल बिल्डिंग ले लीजिए, आप रेजिडेंशियल बिल्डिंग ले लीजिए, तो डेड लोड की कोई बात नहीं है सर यहाँ पर।
यस सर।
डेड लोड तो हम लोग 100% कंसिडर करने वाले हैं।
यस सर।
It is asking about it is making the consideration about only the your live load, dead load की बात नहीं है सर यहाँ पर।
यस सर। यस सर। लेकिन सर वो मैं कह रहा हूँ कि 75% हटा रहे हैं, मतलब मैंने 75% आप हटा रहे हैं लाइव लोड को और 20% ही रख रहे हैं, 25% ही।
हाँ।
इसके लिए मैंने कह रहा था सर कि
वही कह रहा हूँ,
75%
आप कह रहे हो 6% अगर एक फ्लैट में रहते हैं तो सारे के सारे स्किप होना चाहेंगे। ओके।
यस सर, बिल्कुल।
तो अभी क्या होगा कि हो सकता है इसमें, हो सकता है वो तो सारे ही सारे निकल जाएंगे बाहर, फिर भी कोड हम लोग कह रहे हैं कि आप 25% कंसिडर करिए। लाइक 1-2% को हम लोग अंदर ही कंसिडर कर रहे हैं। तो अगर आप देखेंगे तो ये भी और सेफ्टी में ही चल रहे हैं हम लोग।
तो सर लाइव लोड में सिर्फ पर्सन ही इंक्लूड है या सर और भी है ना लोड इंक्लूड होता है?
मैं वही आपको कह रहा था। अब ये आपके ऊपर डिपेंड करता है कि आप स्ट्रक्चर क्या डील कर रहे हो और उसमें लोडिंग क्या डील कर रहे हो। अभी सॉफ्टवेयर कोड तो सारी चीजें इंक्लूड नहीं करेगा। हाँ, यहाँ पर लाइव लोड अगर कहेंगे आप तो मैं कहूंगा कि यहाँ पर हम लोग सिर्फ मीन्स वी आर आवर सेल्फ आर कंसिडरिंग एज अ लाइव लोड, बाकी
ओके
और कोई
सर,
चीज को तो हम लोग लेकर निकलेंगे नहीं बाहर। वी आर ट्राइंग टू
नहीं
सेव
सर,
आवर लाइफ ओनली।
यस सर,
ऐसे मीन्स इमरजेंसी सिचुएशन में हम लोग क्या करेंगे, हम खुद बाहर
नहीं सर, खुद
निकलेंगे
ही
या
निकलेंगे।
चीजों को निकालेंगे?
नहीं नहीं सर, खुद बाहर निकलेंगे।
खुद बाहर निकलेंगे। सो हियर इन इन ओवरऑल केस किसी भी स्ट्रक्चर में अगर आप डील करेंगे, अगर रिडक्शन करने जा रहे हो, सो ओनली यू हैव टू कंसीडर टू योरसेल्फ। हम लोगों को सिर्फ लाइव लोड बीइंग ह्यूमंस को ही लाइव लोड कंसीडर करना है, अदर चीजों को हम लोग रिमूव भी नहीं कर सकते हैं। ठीक है। और दूसरी चीजें
ओके
जो
सर,
है, जो
ओके सर,
आपने एज अ लाइव लोड ली होगी, तो फिर आपको उतना लोड कंसीडर वहां पर रिमेन कंसीडर करना होगा। ओके,
ओके सर, ओके,
क्लियर अभी?
ठीक है सर,
अशोक
क्लियर
सर?
है।
Yes, clear.
Okay. So it is what up to and including 3 kilonewton only 25% you have to consider, and if it is more than 3 kilonewton then 50% you have to consider, 50% you have to left. Okay. So that will the consideration. Come back again to our example. अभी देखिए यहाँ पर क्या था। ओके, सो अब यहाँ पर 12 डेड लोड का मैंने कहा कि डिस्कशन नहीं है। सो हियर आई एम गोइंग टू कंसीडर 12 plus what the code is saying, if it is more than 3 kilonewton per meter square, then you have to consider 50% only, and it is up to and less than 3 only 25% you have to consider. हेलो, सो अभी 4 किलोन्यूटन है। अखिलेश सर कितना कंसिडर करना होगा हमको?
50%.
50%. Okay, so
50% सर,
50%
यस
will
सर,
become, how much will become of 4 kilonewton? 50%,
2 kilometer.
2 kilonewton. So overall it will become what? 14. Hello, right?
Right.
12 plus. So at this particular floor, lumped weight will become what? Lumped mass will become in kilonewton per meter to 14 kilonewton per meter square. Remember this. At this level, same 12 and 4, that will become 14 kilonewton per meter square. At this level, it is again 14 kilonewton per meter square. Now at this level, what lumped mass due to dead load is 12 on the floor level and 10 kilonewton per meter square on the roof. So here dead load is 10 plus similarly live load. Similarly, the lumped weight due to live load is 4 kilonewton all the lower floors and 1.5 at the roof level. So यहाँ पर कितना हो जाएगा?
1.5 into 0.75.
Sorry,
1.5 into 0.75.
25 only we have to consider.
25, yes.
कितना हो जाएगा? So मीन्स इसका 1.5 का हम लोग कितना कंसिडर करना है? ओनली
25%।
75.
25 ओनली, राइट अशोक सर? अखिलेश सर?
ये सर
Right.
फिर से मुझे बतला सर, फिर से मैं समझना चाह रहा था।
क्या हुआ?
नहीं नहीं, फिर से अगेन मैं वो जानना चाह रहा था सर,
अच्छा, ओके।
मतलब
यहाँ
कैसे?
पर क्या है, आपको 12 प्लस 2 14, ये समझ में आ गया?
यस सर,
यहाँ पर भी 12 है फ्लोर लेवल पर, और लाइव लोड
Yes,
कितना है? 10 है, सॉरी 4 है।
हाँ, यस सर,
उसका 2% हो जाएगा, 50% हो जाएगा 2। हियर अगेन इट विल बी व्हाट? 14। हियर अगेन इट विल बी
Yes,
व्हाट?
sir.
12 एंड 4, 4 का हाफ 2, दैट विल बिकम 14। इस लेवल पर आएंगे,
Yes, sir.
टेरेस लेवल पर, रूफ लेवल पर। सो यहाँ पर लोडिंग डिफरेंट कर दिया है। यहाँ पर डेड लोड की वजह से लोड है 10 और लाइव लोड की वजह से है 1.5। तो यहाँ पर कितना रिडक्शन करेंगे हम लोग?
ओके सर, समझ गया सर।
कितना है? इफ इट इज लेस देन 3, हाउ मच यू हैव टू कंसीडर?
25%.
25, राइट अशोक सर? हेलो, हेलो,
0.375, right? Correct.
राइट? नो, रॉन्ग, you all are wrong. Why? Look at this.
रूफ पर लेना ही नहीं.
रूफ पर क्या कहा था हम लोगों को?
Below not to be considered.
At roof you don't need to consider while making the calculation of design forces, seismic design forces. अखिलेश सर,
यस सर, यस
It
सर,
should be
टेरेस
zero
पे
then.
आपको लेना ही नहीं है, तो अब यहाँ पर रिजल्टेंट क्या बचेगा आपके पास?
1.5 only.
सॉरी,
वहाँ लेना ही
आपको
नहीं
लाइव
सर।
लोड ही कंसिडर नहीं करना है यहाँ पर।
हाँ
तो
तो
लैम्डा
सर
मास कितना बचेगा आपके पास?
Only dead load.
ओनली
10.
डेड लोड मीन्स यूर 10। तो यहाँ पर 14,
Dead load.
यहाँ पर भी 14, यहाँ पर भी 14, और यहाँ पर आपको टॉप पर रहेगा 10। क्लियर और नॉट?
यस सर, क्लियर सर।
क्लियर, गुड, वेरी गुड।
हाँ, सर फिर उसने दिया ना 1.5,
सॉरी,
उसने 1.5 दिया ना?
इसने दिया है, इसने लोड कैलकुलेट किया। देखिए, अभी एक कंफ्यूजन आप
Yes.
क्लियर कर लीजिए। बहुत सारी चीजें ऐसी यहाँ पर आएगी जो हम लोगों को अर्थक्वेक लोडिंग और अर्थक्वेक एनालिसिस के लिए कंसिडर करना होगा। ये जो रिडक्शन कर रहे हैं, दिस इज व्हाट फॉर कैलकुलेटिंग द अर्थक्वेक फोर्सेस।
Yes,
और एक
sir.
होता है आपका बेसिक एनालिसिस एंड डिजाइन। तो बेसिक
हाँ, yes,
एनालिसिस
sir.
एंड डिजाइन में जो एक्चुअल है वो आपको कंसिडर करना है। हेलो,
ओके ओके सर,
और
यस
जब अर्थक्वेक आएगा तो अर्थक्वेक में ये कंसिडरेशन होगा। बात समझ में आ रही है आपको?
ओके ओके, यस
तो
सर,
ये दो चीज अलग है। हेलो, क्लियर?
यस यस सर, क्लियर।
ओके,
सर अगर दोनों रहे कमर्शियल और रेजिडेंशियल कंबाइन,
जहां पर कुछ ऐसी सिचुएशन आती है वहां पर आपको क्रिटिकल वन के थ्रू जाना पड़ेगा। ओके,
क्रिटिकल मतलब सर
अभी कमर्शियल क्रिटिकल है तो इम्पोर्टेंस फैक्टर आप क्या लेंगे? ठीक है, यहाँ पर तो कमर्शियल और रेजिडेंशियल के लिए एक ही है। सपोज आपका कमर्शियल और लाइक ओके पॉसिबल नहीं है, बट कमर्शियल पब्लिक बिल्डिंग आ जाता है तो क्या करेंगे आप?
कमर्शियल ही लेंगे सर।
नहीं, पब्लिक लेंगे। पब्लिक के लिए इंपॉर्टेंस फैक्टर आपका क्या है? आप 1.5 लेंगे या 1.2 लेंगे?
1.5 है सर पब्लिक के लिए।
समझ में आ रही है? अगर ऐसा सिचुएशन आ जाता है, आपका स्ट्रक्चर कमर्शियल प्लस पब्लिक हो जाता है, तो आप क्या लेंगे वहां पर?
1.5 सर।
बिकॉज योर VB इज डायरेक्टली प्रोपोर्शनल टू योर I वैल्यू।
यस सर।
सो मीन्स अगर आप I को कम करते हो, मीन्स यू आर गोइंग टू अंडर एस्टिमेट दी VB कैलकुलेशन। हेलो,
यस सर, यस सर।
तो इस केस में ये चीजें ध्यान रखना है। अगर तो ऐसी जितनी भी सिचुएशंस आएंगे, यू हैव टू कंसिडर द क्रिटिकल वन। ओके,
ओके सर।
या कम बैक। अच्छा, तो हम लोग यहाँ पर पहुंचे थे। सो एट W मीन्स एट दिस लेवल, एट दिस लेवल it will become what? 12 plus 50% of this 4, it will become 14, right? सही कैलकुलेशन है ये?
यस सर।
हेलो, it is in
Right.
kilonewton per meter
meters per
square multiplied by in plan area. In plan area is
Floor
what?
area, yes.
Here how many bays are in x direction? 4 means 20. Here it is 3. So 15. 20 by 15. How much it will become?
300 square.
300. So ये 300 in plan area, इसको मल्टीपल करेंगे बिकॉज दिस इज किलोमीटर पर मीटर स्क्वायर मल्टीप्लाइड बाय मीटर स्क्वायर। सो मीटर स्क्वायर गेट कैंसल, किलोन्यूटन weight you will get, kilonewton or means in weight calculation we can call. Okay, hello,
यस सर।
clear or not?
क्लियर सर।
ओके, नाउ अभी फर्स्ट सेकंड एंड थर्ड, फोर्थ भी ले सकता हूं मैं यहाँ पर। W4 सेम वेट आएगा। टेरेस लेवल
नो सर, वहाँ तो लेने की जरूरत नहीं है।
सिर्फ 10 है, मल्टीप्लाइड बाय 300 कितना हो जाएगा ये?
3000।
3000। क्लियर? अभी
Yes.
टोटल सिस्मिक वेट कैसे निकलेगा? 4200 multiplied by 3 times, 3 levels are there, 1 2 3
यस
प्लस आपका टेरेस आ जाएगा 3000 प्लस 4200 मल्टीप्लाइड बाय 3 टाइम्स, टोटल वेट हाउ मच? हेलो,
15,600।
15,600 is total seismic weight of your structure. Clear or not?
यस सर, क्लियर सर।
वेरी गुड। नाउ अभी हम लोगों के पास क्या क्या वैल्यू आ गई? Z है हमारे पास, I है हमारे पास, R वैल्यू है हमारे पास, बट एक्सेलरेशन वैल्यू वी आर नॉट हैविंग as SA by G. Hello,
यस
यस
how
सर।
you can calculate this SA by G? Come back. Okay, so your SA by G value is depends on your time period of your structure. Hello. Under the seismic event. Hello.
Yes, sir.
Time period, and the basic formula for the calculation time period. Okay, time period is what? The number of the time required to complete the one oscillation. Hello.
Yes, sir.
Period and frequency you might have studied in your 11th and 12th. Hello.
Yes, sir.
Okay, period and frequencies. So time required to complete the one oscillation called as fundamental time period. So that's the same thing is here. The time required to complete the one oscillation for a building, okay, called as a fundamental time period. So how to calculate the fundamental time period? The formula has given by your IS code IS 1893/2016. Yeah, see, you all are with me.
Yes, sir.
Yes,
So
sir.
your SA by G value is depends on fundamental time period of your structure, and time period your structure is depends on what type of the soil is there to which your structure is subjected, your structure is constructed. आपका टाइम पीरियड डिपेंड करता है
Yes, sir.
द टाइप ऑफ द सॉइल ओवर विच योर स्ट्रक्चर इज बिल्ट.
Yes,
So
sir.
three terms are there which are depends one over another: time period, acceleration value SA by G, and your type of the soil. Okay, so first thing, the approximate fundamental, तो पहले हम लोग टाइम पीरियड फाइंड आउट करेंगे, देन टाइप ऑफ द सॉइल हम लोग देखेंगे कौन सा है, एंड अकॉर्डिंगली वी विल फाइंड SA by G वैल्यू. हेलो.
Yes, sir.
हेलो.
Yes, sir.
Okay, so the approximate fundamental translational natural period of oscillation, translational in principal direction. Principal direction means what?
X and Y.
Very good. X and Y. So in second shall be calculated by the following expression: bare moment resisting frame means without of infilled masonry wall. Hello. If your
Yes,
structure
sir.
is having only beams, columns, shear wall, but there's no presence of any infilled wall, so that kind of structure called as bare moment resisting frame. Second will become what? Building with RC structure wall means in a structure there is only the provision of structure wall, shear wall. So for that time period you have to calculate using this formula. And for all other buildings means the structure which is having the infilled masonry wall. So अभी हम लोग इसके ऊपर तो फोकस नहीं करेंगे. Second one we have to focus on first and third: the structure without of infilled masonry wall, the structure with infilled masonry wall. हेलो.
Yes, sir.
आप मुझको बताइए, एक स्ट्रक्चर मैं इस तरीके से बिल्ड करता हूं, लाइक which is having the infilled masonry wall. All the other parameters are same. सारी चीजें, डायमेंशन, साइजेस, लोडिंग, everything is same. Only the difference is what? With these two structures, infilled masonry wall, infilled walls. देखिए सब कुछ सेम है, सिर्फ ये स्ट्रक्चर जो है आपका, इट इज हैविंग द इनफिल्ड वॉल्स. मीन्स यहाँ पर वॉल बना हुआ है, यहाँ पर वॉल नहीं है, सिर्फ कॉलम एंड बीम्स आर देयर. टेल मी विच स्ट्रक्चर विल हैव मोर टाइम पीरियड?
लेकिन
बिना इनफिल का होगा, सर.
बिना इनफिल का मोर टाइम पीरियड. ओके,
Yes,
और विथ इनफिल? यस, टेल मी.
इनफिल में सर कम होना चाहिए.
सॉरी,
फिल्म में मोर टाइप होना सर.
इनफिल्ड में मोर टाइम होगा.
नो सर,
फिर
फिल्म में.
फील्ड में. ओके, अक्षय.
फील्ड में होगा सर.
फील्ड में मोर टाइम पीरियड होगा.
जी सर.
ओके, अखिलेश सर.
हाँ सर, बिल्कुल सर, इन फिल्म में होगा और सर डैम्पिंग भी उसका है ना, वो होगा। ठीक है सर, इन फिल्म में होगा
इनफिल में
सर।
मोर टाइम पीरियड होगा। यस अखिलेश सर।
मोर टाइम पीरियड नहीं सर, नहीं होना चाहिए सर,
अशोक सर।
कंफ्यूज हूँ सर।
वेरी
No
बेसिक
idea.
थिंग। नो आइडिया।
No.
You should answer, I think. Yes, Ritesh. Very simple.
सर इनफिल जो नहीं होगा सर, उसमें ज्यादा होना चाहिए।
Okay. Tell me, which building will deflect more, either light building or heavy building?
Light building.
लाइट बिल्डिंग सर।
Light building. Okay. Light building will deflect more. अभी deflect more होगा, so उसका
तो टाइम
पोजीशन रिकवर करने के लिए ज्यादा टाइम लगेगा कि कम लगेगा?
ज्यादा लगेगा।
ज्यादा लगेगा
ज्यादा
सर।
लगेगा। सर सिंपल थिंग, दिस इज हैविंग द मोर वेट। यहाँ पर आपको मोर वेट हो गया, मीन्स इट इज मोर स्टिफ इन कंपैरिजन ऑफ दिस वन।
Yes,
और
sir.
जैसे ही स्टिफ होगा, मैंने आपको बताया स्टिफनेस मीन्स व्हाट, रेजिस्टेंस टू
Deformation.
deformation. So it will deform more less, it will deform more in with
Yes, sir.
all other parameters are same. So ये क्या होगा, ज्यादा डिफॉर्म होगा या कम डिफॉर्म होगा? कम डिफॉर्म होगा तो टाइम पीरियड कम लगेगा वन ऑसिलेशन कंप्लीट करने के लिए, और ये ज्यादा डिफॉर्म होगा तो टाइम पीरियड आपको ज्यादा लगेगा। गेटिंग और नॉट?
Yes, sir.
Cutting.
Yes, sir.
Simple. So that's the thing is present here. Let me show you. Okay, clear these all. Just come down. So bare moment resisting frame without infilled masonry wall. Okay. So if RCC building is there, if steel structure is there, if composite structure is there, for these formulas are there. It is called this formula you can use as per your type of structure. Very simple. Nothing is there. Only this H you have to consider. H here it is given height of building, but I am not going to call it as height of building. I am going to call it as seismic height. Why I am going to call it as seismic height? You will come. You will understand this later. Okay. Here I am not going to call it as height. I am going to call it as seismic height. Okay. I will let you know. Wait. Second, for all other buildings, means the structure which is having the infilled masonry wall. So for that we have to use this formula. 0.09 H is there, which is normal height, but I am going to call it as seismic height. And this is what direction, means dimension of your overall dimension of your structure at the plinth level. Base dimension of the building at the plinth level in the considered direction of loading. अगर आपको x में earthquake कंसिडर करना है तो ये कंसिडर करना पड़ेगा, ये डायमेंशन लेना है। अगर आपको y में लोडिंग कंसिडर करना है तो ये डायमेंशन लेना होगा। इज दैट ऑल ओके?
Correct.
Yes, sir.
हेलो।
Yes.
Yes, sir.
Okay, so why I'm calling it as seismic height? First, let try to understand this seismic height. So because there is some concept beyond of deciding the height of structure, that's why I'm going to call it as seismic height. If this concept is not there, then I can call it as simply height. But yeah, there is a concept. It is variable. It will change based on your situation. That's why I'm calling it as seismic height. क्या situation है? Okay. So if your structure is of this kind, then you have to consider this total height. What difference is there among these all figures? Try to understand. If the structure which is having the basement, hello,
Yes, sir.
which is having the, क्या difference है ये दोनों figure में, ये first and second. So try to understand. If your structure is having the basement, but what, this is your property, this area is what, it is suppose your property, and you are going to keep this excavated area as means blank even after the completion of the work. Hello.
Yes, sir.
Hello. And you are going to
Yes,
put
sir.
your retaining wall, means away from the line of outer line and peripheral line of your structure. So आपने यहाँ से excavation किया, so आप वापस means you are not going to refill this area, this area by soil mass, and if it is not refill is there, so there will be no any lateral force or lateral pressure to this wall, right? So without of base wall or basement wall, you can build this structure. Hello. Hello.
Yes, sir.
So in this situation,
Sir.
we have to consider overall height. Hello. From this point to
Yes, sir.
this, getting or not? In
Yes,
the
sir.
second
Getting.
case, here what this is not your property. Hello. It is temporary retaining wall. Hello. After
Yes,
the
sir.
completion of work, you have to refill this area. Hello.
Yes, sir.
So this earth mass will apply the pressure to this wall. अगर आप यहाँ पर जनरल वॉल ब्रिक वॉल कंसिडर करते हो, so that will not capable to withstand this lateral pressure of the earth mass. Am I right or wrong, अशोक सर?
Right.
ओके. सो इसके लिए यहाँ पर वॉल लेना पड़ेगा. दिस इज एक्चुअली द रिटेनिंग वॉल, बट या इसको हम लोग बेसमेंट वॉल कहते हैं. हेलो, क्या कहते हैं हम लोग इसको?
Right.
Basement wall.
Basement wall.
Basement wall. So this is again retaining wall is also having the same purpose, and your basement wall is also having the same purpose. Okay, but this retaining wall normally we are constructing permanently, but यहाँ पर क्या करेंगे, after completion of your work हम लोग इसको remove कर देंगे. Hello.
Right.
Yes, sir.
And then in this situation we have to consider this h as a height of your structure. Is that all okay?
Yes, sir.
Yes, sir.
और ये सारी situations आपको दी हुई है. Okay, accordingly we have to decide the height of your structure. I think आपको समझ में आ गया होगा. Okay.
Right.
Okay.
Yes.
So this is called as seismic height of your structure. और ये डायरेक्शन, जिस डायरेक्शन में आपको लोडिंग कंसिडर करना है उसी डायरेक्शन का आपको डायमेंशन लेना है. सो दैट विल गिव यू टाइम पीरियड. अभी आते हैं हम लोग के एग्जांपल पर. ट्राई टू अंडरस्टैंड इन डिटेल. Okay, so here it is what time period 0.09 h. So here normal situation, total height we have to consider. Total height is how much? 4.2 plus 3.65, 3.65, 3 point, that much complication is not here. So directly we have to add this all value 4.2, 3.65, 3.65. This combines. If you add these all values, you will get what? 15.15. Hello, you can check it. Hello.
Right,
Yes,
sir.
sir.
Okay, you can check it. Okay, square root of consider direction. x डायरेक्शन में कैलकुलेट कर रहे हैं तो कितना डायमेंशन लेंगे? हेलो,
20, sir.
20. Okay, so we are getting value 0.305 seconds. TAY means in y direction. Same formula will be there. 0.09 height will be there. Square root 15. 15 for y direction. We are getting this 0.352. Okay, why I am using this formula? Because in question we have given it is what infilled with brick masonry. Hello.
Yes, sir.
Clear? That's why I'm taking this. Okay. Actually, our objective is not to calculate this TA time period. Our objective is to calculate SA by G value in both the direction, but that depends on your time period. So come back to your IS code again and look at this. If you are calculating by equivalent static method, so you have to use this. If you are calculating by response spectrum method, you have to go with this. But I will let you know what are the different methods. Right now the example that we are solving is as per the equivalent static method. Okay, remember this. I will let you know what are the different methods, and so many things we have to discuss. We will cover it later. But yeah, for equivalent static method, it is what? Hello. For rocky soil, for the medium stiff soil, what type of the soil is there for our structure?
medium
Medium stiff. So for the medium stiff, SA by G value will be for the medium stiff if time period is in between 0 to 0.55. Hello.
Yes,
See,
sir.
for x direction it is 0 to 0.55 or not?
Yes, sir. है.
ये भी 0 to 0.55 है कि नहीं?
Yes, sir.
तो दोनों केस के लिए आपका टाइम पीरियड क्या बनता है?
2.5
2.5.
सो हम लोग किसी भी डायरेक्शन को ले सकते हैं. दैट वी आर गोइंग टू कंसिडर 2.5. ओके, नाउ कंसिडर क्रिटिकल डायरेक्शन डिजाइन acceleration in x direction and hence analysis and design is need to done in this direction. Okay, in next direction we are going to do the calculation. Hello. हेलो.
ओके सर.
ओके, सो अभी देखिए ए एच हम लोगों को मिल गया, जेड बी वैल्यू सारी वैल्यूज हैं, सारी वैल्यूज को आप पुट करेंगे, फाइनली आपको क्या मिलेगा, वी बी का वैल्यू मिलेगा. वी बी इज इक्वल टू बेस शेयर वैल्यू 1123.2 किलो न्यूटन फोर्स इज देयर, lateral force at the base of your structure. Now half part of this problem we have completed, that is what we have calculated base shear value. Now we have to distribute this load over the height of
See,
your
but
structure.
y direction is more giving, will give more base shear.
Sorry.
In y direction, if we see the above, SA by G is more in y direction. TAX is 0.305. Okay. Sorry, correct.
Actually, we are
What?
taking 2.5, sir. Okay.
No. For TAY, it is 0.352 seconds.
Okay. So that one the critical one. Hello.
Hmm.
That
How
direction
we
will
are,
be sorry,
how we are deciding the critical direction? Based on
based
which
on the time
number?
period in the direction where you are getting less time period. Hello.
I see. Right. Correct.
That will be the critical one.
Okay.
Because
Understood.
okay, because your SFIU value is same for both the direction. Okay.
Right.
Yeah.
Right.
So okay, so finally we are getting VB value. Now IS 1893/2000 पेज नंबर 23 क्लॉज नंबर 7.6.3 आपको आप देख लीजिएगा इसको. ओवर द हाइट इफ यू वांट टू कैलकुलेट द लैटरल फोर्सेस, सो दिस इज अ फॉर्मूला टू कैलकुलेट द डिस्ट्रीब्यूशन ऑफ द लैटरल फोर्सेस. Weight of any particular floor multiplied by height of that particular floor from the base, square root of that divided by summation of total this multiplication, these values multiplied by VB. Okay, come to this table, you will come to know. At fourth floor, total weight is what? Lumped mass total
1000 kilonewton.
3000.
3000. Okay, at terrace total height from the base
15.15. ठीक है सर.
Correct.
weight multiplied by HI square of that, but HI means this fourth floor particular floor, this much you are getting. For this third floor we are moving from top to down. For the third 4200, height will be reduced to 11.5, multiplication with the square of this HI, you will get this with this all this we are getting, we are taking the summation of all this value to have this value. Right or wrong? Very simple. Hello.
Yes sir.
Okay. QI, how you can calculate the QI? This particular value divided by, this particular value, take the calci in your hand, this value divide by this total summation
157.
value multiplied by VB 1123.2. check it whether right or wrong. Is it right or
It
wrong?
shows me just above. I want to see the VB value. Oh,
VB 1123
11,
1123.2.
1, 2, 3.
Is it right or wrong? Okay, check it. Now this value divided by this total value multiplied by VB, you will get this. This value divided by this total value multiplied by VB, you will get this value. This value divided by this total value multiplied by with the VB 1123.2, you will get this value. Now from top again take this value, same value here. Now add this value, this two value, you will get this value. Then add this two value, you will get this value. Then add this two value, and final cross check you will get at the base. The base shear value as 1123.2. Hello.
Correct. Checked. Yes.
Clear?
Correct values. Yes.
Yes sir.
That's the calculation, and your software is also doing this thing. Actually time's not allowing to show, otherwise I will give the proof by the software, same result. Okay, but okay, this is your job, आप करिए इसको. Okay.
Okay.
यस, ठीक है. सो देखिए यहाँ पर एक चीज करेक्ट कर लीजिएगा आप. This is 3000, not 4200. Hello.
Correct.
Okay, this 3000. Later on, everything is same. This is the idealized diagram showing the lumped masses. Idealized diagram showing the lumped masses. This is your frame, and this is your lateral forces over the height, and this is your base shear value. Getting or not? Is that all clear?
Clear.
Yes, sir.
Is there any doubt and question?
सर बिल्डिंग का टाइम पीरियड का कोई रेंज है?
वो सारी चीजें आगे देखेंगे हम लोग, टाइम पीरियड का क्या होता है.
ओके सर.
Yes. Is there any question and doubt? Hello.
No, sir.
Yes. Okay, one more thing we have to understand, the concept of diaphragm. Hello.
Yes, sir.
Yeah. What does the diaphragm? So it is nothing, just the consideration is there, like if the lateral forces is going to act the floor level. अभी आपको समझ में आ गया lateral force कहाँ पर act होगा?
जहाँ लंब मास होगा.
Floor level पर होगा, right?
Yes, sir. Yes, sir.
Okay. So your lateral force is not having any path to be transferred from the structure. Like it is the lateral force. अभी हम लोगों को पता है this is the lateral force. But the basic concept for the transfer of the load is what? In the gravitational direction. From slab to column, column to beam, slab to beam, beam to column, column to foundation. Am I right? But here
Yes,
the
sir.
load is going to be act in the lateral direction. ये तो vertical path में नहीं जा रहा है. अब क्या करेंगे आप? So there will be the concept of floor diaphragm come into the picture, where the floor diaphragm will make your particular floor all the different elements to behave as a unit element. All the different floor slabs which are what in separate mode. If you are going to assign the floor diaphragm, if you are going to consider the floor diaphragm, so what the floor diaphragm will do is going to create is going to make these all different slabs as a unit element. Hello.
Like the lumped mass.
No. That's another thing. What it will do, it will make it as what? Unit element, and it's going to create any means it is going to create a center of mass point. Hello.
Okay.
Actually what will happen here, यहाँ पर इसका center of mass generate होगा. Hello.
Correct.
Center of mass इस slab का यहाँ पर create होगा. Center of mass इसका यहाँ पर create होगा. ओके ये स्लैब अगर ले लेता हूं तो सेंटर ऑफ मास सपोज जस्ट फॉर एग्जांपल यहां पर होगा. इसका सेंटर ऑफ मास इफ सपोज लाइक दिस काइंड ऑफ ज्योमेट्री इज देयर, सो सेंटर ऑफ मास सपोज यहां पर आ गया इसका. सो योर लैटरल फोर्स इज सपोज गोइंग टू एक्ट मींस इट इज गोइंग टू एक्ट इन लैटरल डायरेक्शन. सो अब किस पॉइंट पर एक्ट होगा, ये यहां पर एक्ट होगा, तो अब ट्रांसफर कैसे होगा? इफ सपोज इट इज गोइंग टू एक्ट एट दिस पॉइंट, तो ठीक है अब यहां से कहां ट्रांसफर होगा ये? ओके यहाँ से यहाँ पर ये कॉलम पर आ जाएगा, ये कॉलम पर आ जाएगा, ये कॉलम पर, ये कॉलम पर. सो इट इज राइट. टोटल lateral load is going to be carried by these 4 columns only. Will it work?
No.
sir.
No. So what the floor diaphragm is doing actually, it is actually making all the separate slab as a unit element. This is what consideration. अभी ये भी actual में नहीं हो जाएगा पप्पू.
Yes, sir.
ये भी
सर
एक्चुअल
इसमें
में
तो
नहीं हो
बीम भी
जाएगा.
इंक्लूड होगा ना, बीम भी
Yeah,
इंक्लूड होगा सर.
for the calculation of the seismic loads only, for the transfer of seismic forces only. Getting? उस टाइम पर खाली इसका कंसिडरेशन होगा. हेलो.
Okay, sir.
Okay, so what it will do, it is going to create a common center of mass. जो भी ज्योमेट्री होगा उसके अकॉर्डिंग एक कॉमन सेंटर ऑफ मास क्रिएट करेगा. हेलो.
अच्छा सर इसमें इंक्लाइन स्लैब भी कंसीडर करता है?
नहीं.
ओके
नहीं. ओके सो क्या करेगा, ये सेंटर पॉइंट को जनरेट करेगा और ये सेंटर पॉइंट से सारे कॉर्नर्स को ज्वाइन करेगा. अब क्या होगा, सारे पॉइंट्स पर आपका लोड ट्रांसफर होगा एंड इट विल बी कंटिन्यू इन यूजुअल वे फ्रॉम टॉप टू डाउन. क्लियर? फ्लो डायफ्रागम कॉन्सेप्ट.
Yes, sir.
क्या करता है, कुछ भी नहीं है, सारे स्लैब्स को एक कॉमन पॉइंट देता है वो पॉइंट पर आपका लैटरल फोर्स आकर एक्ट होगा और फिर वहां से सारे पॉइंट्स पर डिस्ट्रीब्यूट होगा. इज दैट ऑल ओके अशोक सर?
ओके
Oh,
सर, लेकिन जो अपना स्टेयरकेस इंक्लाइंड रहता है तो वो हम लोग कंसीडर करेंगे
नहीं नहीं, वो कंसिडर नहीं होता है. योर फ्लोर डायफ्राम विल बी असाइन टू ओनली द फ्लोर स्लैब्स. ओके,
उसको
इट इज
निगलेक्ट
नॉट.
करेंगे,
नहीं, उसको नहीं अप्लाई करेंगे,
उसको निगलेक्ट करेंगे सर.
निगलेक्ट करेंगे. यस
ओके, सभी फ्लोर पे.
यस यस, अगर आप उसको अप्लाई करेंगे तो एरर आएगा आपका.
यस, क्योंकि मैंने किया था तो एरर आ रहा था सर.
आएगा, एरर आएगा, बिकॉज दिस इज नॉट एक्सेप्टेबल. ओके, so is that all clear?
यस
So we'll
Clear.
continue. But okay, tomorrow's session will be there. Okay, remember Friday is there, but still we are going to conduct this session. Okay.
okay.
Okay. So in evening session will be there. I will let you know. Okay. If delay in sharing the link, so wait. But the session will be there. Okay. Hello.
ओके सर.
ओके सर.
ओके सर.
So,
Yes, Nazia.
Salaam. So, RCDC जो सॉफ्टवेयर है ना सर, तो इसको इंस्टॉल करने का मेथड क्या है सर? मतलब मैं अभी तक इंस्टॉल नहीं किया, ये तो आपसे पूछूं.
आपने इंस्टॉल नहीं किया है.
जी सर, मीन्स is it simple or it is complicated kind of
I will share a contact number. You have to discuss with that team member. Okay. He will help you to install it.